Hi, so for today we're going to talk about the conjugate of complex numbers, and this is still a part of our advanced engineering mathematics lecture. So let's get started. Okay, before we get started, if you are new to my channel, please don't forget to subscribe to my channel for more math and engineering tutorials. So let's get started. So how do we evaluate this complex number involving conjugate? So it's pretty much the same. It's just that we know that 1 minus 3i, and this sign is what it means is the conjugate of this. So the conjugate of 1 minus 3i would be 1 plus 3i. So before we evaluate the complex number, we must first apply the conjugates. And that is all over 1 minus I. And of course, in order for us to evaluate this, we are going to multiply this by the conjugate of the denominator. That's 1 plus I over 1 plus I. Okay, that is the rule. We have to eliminate that I on the denominator. So we have to apply FOIL here. So we have 1. Then E outer, we have plus I. Okay. The inner, we have plus 3I and plus 3I squared for our last term. And that is all over 1 minus I squared. And then evaluate. So we have 1 plus 4i. 3i plus I is 4i. We know that I squared is equal only to negative 1. So might as well we have to substitute negative 1. So we have negative 3 plus 1 is negative 2. That is plus 4i all over 1 minus negative 1 is 2. So we can further simplify this. We can factor out 2. We have negative 1 plus 2i. Okay, all over 2 times 1. Okay, so we cancel 2. Then we have an answer finally, negative 1 plus 2i. So this would be our answer for our problem number 1. So for number 2, let's try again to solve. Our given is the conjugate of 1 minus I all over I plus quantity, okay? Conjugate of the whole term 1 plus I all over I. Okay. So how are we going to evaluate? So this is the conjugate of the whole, including the numerator and the denominator. So first, we need to evaluate the conjugate of the numerator for the first term. We have 1 plus I all over I. Okay, and then plus properties of conjugate, we can distribute this on the numerator and the denominator. So what are we going to do is simply we have 1 plus I conjugate, okay, and the conjugate of I on the denominator, and evaluate its conjugate. That's one property of conjugates. So we have 1 minus I, okay, all over we have negative I. Okay, so again, in order for us to solve this, we need first to eliminate the I on each of the denominators. So we'll be having 1 plus I all over I, and this would be multiplied, okay, this would be multiplied, okay, to the conjugate of its denominator, negative I, for the first term. And then we have what plus 1 minus I all over negative I, and the conjugate of negative I should be negative I, or positive I mean. So positive I over positive I. And then evaluate. Okay? So what are we going to do here? Simple numerator times numerator, denominator times denominator. So we have negative I minus I squared all over negative I squared. That is plus here. We have I minus I squared all over. We have negative I squared. But I squared, as we all know, that's equal to negative 1 all over negative is negative 1, plus we have I minus negative 1, then we have negative of negative 1. So as you can see, the denominator is only equal to 1. So we can rewrite this as I plus 1, or 1 minus I, this one, plus, okay, and then we have 1 plus I. 1 plus I. So if we're going to evaluate this, 1 plus 1, that's 2. Negative I plus I would be cancelled. So hence we have an answer that is equal only to 2. Okay, let's proceed with number 3. So proceed first with the given. If z sub 1 is equals to negative 1 plus I, and z sub 2 is equal to 2 minus 3I, we're going to evaluate number 3. Quantity is z sub 1, conjugate of z sub 1 over I times z sub 2. Okay? So first, we're going to get the conjugate of z sub 1. So z sub 1's conjugate would be negative 1 minus I all over I multiplied by z sub 2, 2 minus 3I. So evaluate negative 1 minus I. So we have 2I minus 3I squared, and evaluate the I squared. 2I minus 3, 2I minus 3 times negative 1. Okay? So we have now negative 1 minus I. This would be positive 3 plus 2I. Okay? Then we're going to evaluate this by multiplying it by the conjugate of the denominator 3 minus 2I over 3 minus 2I. So simple, um, again, simple multiplication of fractions. So we have negative 3, that's the first. The outer is plus 2I. The inner is negative 3I. And the last one is positive 2I squared. Okay, let me just rewrite this. 2I squared all over we have 9, okay, minus 4I squared. Evaluate this I squared. So first simplify this. We have negative 3, 2I minus 3I, that's minus I. We know that plus 2 times negative 1. And then we have 9 minus 4 times negative 1. Okay? So we have now negative 2 minus 3, that's negative 5 minus I. Okay? And then we have 9 plus 4, because this becomes plus because of the negative 1, that's 13. So our answer would be negative 5 over 13 minus 1 over 13I. So this should be our answer for this problem number 3. For number 4, okay, let's try to have another problem. We have I multiplied by the conjugate of z sub 1 all over z sub 2 minus I. Okay, going back to our given, these are our given. I multiplied by the conjugate of z sub 1 as negative 1 minus 1 all over the z sub 2, 2 minus 3I multiplied by or minus I. Minus I. So we have negative I minus I squared all over we have 2 minus 4I. But we know that I squared, okay, is equal to negative 1. Okay, and this would become 1 minus I all over 2 minus 4I. Okay, and then finally we solve this by multiplying again by its conjugate, the denominator's conjugate. We have 2 plus 4I all over 2 plus 4I. Then evaluate. So you need to evaluate that. So first we have 2. Outer we have plus 4I. Inner we have minus 2I. And last term we have negative 4I squared. And that is all over 4 minus 16, okay, I squared. Okay, and evaluate this, simplify this. So we have 2, then we have 4I minus 2I, that's plus 2I, then we have negative 4 times negative 1 all over 4 minus 16 times negative 1. So this would become plus 4 plus 2, that's 6 plus 2I all over 20. Okay, 20. Okay, so we can further simplify this by factoring 2. We have 3 plus I all over. We have 2 times 10. So the 2's will cancel. So we have the result as 3 plus I over 10 or 3 over 10 plus 1 over 10 I. This should be the result of our problem number 4. So let's go now to problem number 5. For problem number 5, we have conjugate of z sub 1 all over z sub 1 plus z sub 2 plus quantity the conjugate of z sub 2 all over z sub 1 plus z sub 2. So going back to our given, okay, we have this given negative 1 plus I, then z sub 2 2 minus 3I. So we're going to substitute it. The conjugate of z sub 1 is actually negative 1 minus I. That is all over z sub 1 plus z sub 2. We have negative 1 plus I. Negative 1 plus I, and that is plus 2 minus 3I. Okay, for this term. And then plus the conjugate of z sub 2, that's 2 plus 3I. And then we have the same for the denominator as the first term. Okay, so what are we going to do here? Simplify negative 1 minus I. So we have negative 1 plus 2, that is 1. Okay, then we have I minus Ti, that's 1 minus 2I. Okay, and the same for this, 2 plus 3I, the same for the denominator. So we can combine this because they have the same denominator. Negative 1 minus I plus 2 plus 3I all over 1 minus 2I. Simplify, and then we have negative 1 plus 2, that is 1. Negative I plus 3I, that is plus 2I all over 1 minus 2I. And of course, we're not yet done. We're going to multiply this, as we know, by the conjugate of the denominator. So we have multiplied by 1 plus 2I over 1 plus 2I. So we have an answer of 1 plus, we perform the FOIL of this, our answer should be 1 plus 4I plus 4I squared all over 1 minus 4I squared. Okay, then we have to evaluate the I squared as negative 1. Then we have this answer. So we have 1 minus 4, that's negative 3 plus 4I all over, we have 5. Okay, so our answer should be negative 3 fifths plus 4 fifths of I, and that is our answer for this problem. So let's try another problem. Okay, for number 6, if z sub 1 is equal to 1 plus I and z sub 2 is equal to 2 minus 2I, then we're going to evaluate the modulus of 1 minus z sub 2 over the conjugate of z sub 2 minus 1. Notice that we have now a modulus. So our answer should be a real number, positive real number. Okay, so we have first, we have 1 minus a sub 2, that's 2 minus 2I. Be careful with the minus sign. You have to distribute that. The over the conjugate of z sub 2, that's 2 plus 2I minus 1. Okay, so what will happen here is we have 1 minus 2, okay, plus 2I all over 2 minus 1, that's 1 plus 2I. The modulus of that. And of course, if we simplify this, that is negative 1 plus 2I all over 1 plus 2I. Okay? And we know what to do with this in order for us to evaluate this. We need to multiply this by the conjugate again of the denominator. So what will happen here is we have 1 or negative 1 plus 2I all over 1 plus 2I. Okay, and then we have to multiply it by the conjugate. So we have 1 minus 2i all over 1 minus 2i. Don't forget the modulus. Okay. Evaluating that, so we have negative 1, okay, and then minus 4i squared, because this is a difference, okay? No, we have to evaluate it because this is negative 1 and this is 1. They are not they are not entirely the same. So we have to perform still the FOIL method. So we have negative 1 first, outer, we have plus 2i. We have inner, okay, that's plus 2i. Then we have the last, that's negative 4i squared. All over, okay, this is only difference. So we have 1 minus 4i squared. Simplify, so we have negative 1. We have 2i plus 2i, that's 4i. And then we have minus 4 times negative 1. On the denominator, we have 1 minus 4 times negative 1. So we have 4 minus 1, that's 3, plus 4i. All over, this should be 5. Okay, the modulus of 5. So in order for us to get the modulus of that, so we can rewrite this as 3/5 plus 4/5 I. So we know that this is our x, this is our y. In order for us to get that, so we have to square x, okay, plus the square of y, then we square it out, okay? So what will happen here is that we have 9 over 25 plus 16 over 25. So 9 plus 16, so we can add this because they have the same denominator, 25. 9 plus 16 is 25 over 25, of which we know that that should be the square root of 1, and the square root of 1 is only equal to 1. And that's our answer for this problem. Okay, let's get another problem, number 7. So we have 1/2 multiplied by the modulus of z sub 1 all over the conjugate of z sub 1. Okay, let me just rewrite this. So we have z sub 1 all over the conjugate of z sub 1 plus conjugate of z sub 1 all over z sub 2. And then take the modulus of that and multiply it by 1/2. So first, before we multiply 1/2, we need to evaluate this inside of the modulus. Okay, so we have 1/2 multiplied by say sub 1, our say sub 1, 1 plus I, whole over the conjugate of say sub 1, that is 1 minus I, okay, that is plus say sub 1 conjugate is 1 minus I all over say sub 2. Our say sub 2 is 2 minus 2I. Okay, so first, what we need to do is to evaluate first the first term, okay, multiply it by its conjugate, denominator's conjugate, 1 plus I, 1 plus I, and that is plus 1 minus I all over 2 minus 2I, and we multiply it by the conjugate of the denominator, 2 plus 2I, 2 plus 2I. Okay? So, what we're going to do, simply evaluate. So, 1/2 the modulus of, we have 1 plus 2I plus I squared. If we do this, okay, they are entirely the same. So, we can have the shortcut for FOIL. So, we have 1 minus I times 1 plus I, that's 1 minus I squared. Plus, we have to perform FOIL on this. The first, the outer would be plus 2i. Inner would be negative I times 2, that's minus 2i. And the last would be negative I times 2i, that's plus or minus 2i squared. Minus 2i squared. Then all over, we have 4 minus 4i squared. Take the modulus of that. Okay, so evaluate this. We have 1/2. Okay, that's 1/2 multiplied by the modulus. Oops. multiplied by the modulus. So we know that this I squared is equal to negative 1. So it's positive. Positive times negative would be negative. So this is negative 1 plus 1. We know that these two would cancel. 1 minus 1. Okay? So leaving 2i. Okay? And we know that this should be 1 minus negative 1. Okay? That is plus. Of course, we can also simplify 2i minus 2i. Positive 2i minus 2i, that's 0. So we are left with 2 minus 2i, or 2 times negative 1, because I squared is equal to negative 1 all over 4 minus 4 times negative 1. So we have 1 half the modulus of 2i all over 2. These 2's will cancel. Okay? Cancel. So we have an I for the first term. So we have negative 2 times negative 1, that's positive 2. So positive 2 times plus positive 2, that's 4. All over, we have negative 4 times negative 1 is 4. 4 plus 4 is 8. Okay? So we have 1 half the modulus of I. We can reduce this into lowest term, we have 1 half. So we perform that. How are we going to write this? We have 2i plus 1 over 2. Okay, the modulus of that. So in other words, we have 1 half the modulus of, we can rewrite this as 1 half plus, okay, plus I. It's still the same here. Okay, so we need to get the modulus of this before multiplying by 1 half. So the modulus of this would be, this term would be 1 half squared plus 1 squared. Okay. Our x here is 1 half. Our y here is 1. So hence we have 1. So if we're going to multiply that, evaluate that, that is 1/4 plus 1. Okay. So we know that this would be equal to 1 half multiplied by the square root of 5 over 4. Okay, and then we can evaluate this as, we have square root of 5, okay, over square root of 4. That's the same with this. So we have 1 half square root of 5 over 2. Okay, because we can evaluate square root of 4 as 2. So we have square root of 5 over 4. So that is our answer for this problem. And as for our last problem for today's video, so we have number 8. We have the modulus of the conjugate of z sub 1 multiplied by z sub 2, plus we have I z sub 1 minus I z sub 2 all over the conjugate of the sum of z sub 1 and z sub 2. So this is z sub 2. Oops. We just rewrite this. Z sub 1 plus z sub 2. Then we have plus, okay, the conjugate of the product of z sub 1 and z sub 2. So what are we going to do is we can use the properties of conjugate here. This one, the product of the conjugate of the product of z sub 1 z sub 2 can be rewritten as individually the conjugate of z sub 1 multiplied by z sub 2 plus I z sub 1 minus I z sub 2 all over, we have z sub 1. This could be also rewritten as z sub 1, the conjugate of z sub 1 plus the conjugate of z sub 2, plus we have conjugate of z sub 1 multiplied by conjugate of z sub 2. And don't forget the modulus. So the modulus should be our final answer here. So it should be a real number. So taking back in our given, I plus 1, 2 minus 2i. Let's take a look back. So we need to substitute that. Okay, we need to substitute our values. So what are we going to do? We have z sub 1, the conjugate of that, that is 1 minus I. conjugate of z sub 2, that is 2 plus 2i plus I times z sub 1, which is 1 plus I minus I times z sub 2, that is 2 minus 2i. Okay, all over conjugate of z sub 1, that is 1 minus I. Okay, plus conjugate of z sub 2, that's 2 plus 2i. Okay, and then plus, okay, the same thing here, 1 minus I multiplied by the conjugate of say Z2. Of course, don't forget the modulus. Okay, we're going to solve this. So if we solve this, we have FOIL method. So the first one would be 2, outer would be plus 2i, inner would be negative 2i, then last would be minus 2i squared, plus we need to distribute this would be I, plus I squared. And the last one here, we need to distribute I together with its sign because that is a minus. So we have negative 2i minus or plus 2i squared. Negative times negative would become plus. Okay. Then on the denominator, we can add this. Okay. First, no, we can add this. So we have 1 plus 2, that's 3, minus I plus 2i, that's plus I. Then that is added to the sum of this, so which is the same to this one. So we have 2 plus 2i minus 2i minus 2i squared. Take the modulus of that. So as you can see here, we can cancel this. Okay, that would be 0. Okay, is there anyone else? Negative 2i squared. Okay, we have plus 2i squared would be cancelled. Okay, so and we evaluate it. So let's try. Modulus of 2, okay, 2. So what we're going to have here, 2 plus we have, this is would become negative 1. So 2 minus 1 would be 1. Then we have plus I minus 2i would be minus I. And for our denominator, of course, we have 3 plus I. Then we have plus 2. Okay. Minus 2 times the negative 1 because of I squared. So we have 1 minus I all over 3 plus 2 is 5. Okay. And then we have 2 times negative 2 times negative 1, that is plus 2. And then we have plus I. So we have 1 minus I all over 7 plus I. So get the modulus of that. Okay. But before we get the modulus of that, again, we need to solve it by multiplying the whole equation by the conjugate of its denominator. Let me just rewrite this. So we have a 1 minus I all over 7 plus I multiplied by the conjugate of the denominator. So we have 7 multiplied by 7 minus I all over 7 minus I. And of course, it's modulus. Don't forget the modulus. So we have first 1 times 7 outer, negative I times 1, that's minus I inner, minus 7i. Last, we have negative I squared all over 49, okay, minus I squared. So this would be 7, or this would be positive 1, I squared. So we have, let me just rewrite, 7 minus 7i, okay, 7, negative I minus 7i, that's negative 8i. Then we have negative times negative 1, minus times negative 1. This would become 49 minus times negative 1. So we have, well, of course, this should be positive. My mistake. Okay, this should be positive because negative I times negative I would be positive I squared. Okay, so we have 7 minus 1. That should be 6 minus 8i all over 49 minus negative 1. Okay, minus, we have 50. Then we can factor out 2. Okay, 3 minus 4i all over 2 times 25. Okay, we can see that the 2's would cancel. And then we have, finally, we have the modulus of 3 minus 4i all over 25. So we can have now as the modulus of 3 over 25 minus 4 over 25i. So if we get the modulus of that, so we have 3 over 25 squared plus we have negative 4 over 25 squared, taking the square root of that. So we have 9 over 25 squared is equal to 625. So we have 625. Okay, plus 16 over 625. And then we have the square root. So we have square root of 25 over 625. And if we evaluate that, simplify the fraction inside, we have um, 1 over 25. By the square root, we have this 1. Our answer should be 1/5. So that's the modulus for our problem number 10. Okay, so thank you so much for listening. Don't forget to subscribe on my YouTube channel if you are new to my YouTube channel. So this is a fun topic, complex numbers, and I hope you guys learn something from today's videos. Again, this is Engineer Abat. Don't forget to subscribe to my channel. So thank you so much and God bless.